I play table tennis. It's one of those sports that looks simple until you're actually trying to get better at it, and then you realize how much detail is there. And when you're training, there's no real record of what you did. You finish a session with a rough feeling and that's it. I'm also an Edge AI engineer. At some point, those two things collided. So I built a bat that tracks my stroke movements for me. The real challenge here was fitting everything inside a bat handle. Arduino Nano 33 BLE Rev 2 with built-in 6-axis IMU, that's what makes it possible. Add a small OLED, a 300 mAh LiPo, a boost converter and a power switch, all inside a 2-part handle I designed in Fusion 360 and 3D printed. I ordered a real blade without a handle, glued on proper rubbers to make it feel like a professional bat setup. Now let's assemble the hardware. The OLED screen is wired to the I2C bus and a 5V power. On the other side, we have the boost converter and battery charger circuit, the battery and a power switch. The handle is 3D printed in 2 halves and all the electronics are enclosed. Just like any proper table tennis bat, now we still need to glue in the rubbers. Now here's what the fully assembled hardware looks like. I have 2 handle variations. The left one is a flared handle and the right one is a straight handle. Now to train the model, we needed labeled stroke data. I wrote a simple web app that connects the Arduino over Bluetooth. You input the stroke type, like forehand smash, hit the pulse, and the Arduino detects each swing using acceleration threshold. It captures 500 millisecond window, 200 before the acceleration and 300 after the acceleration. You can then download a zip of the CSV files and you have all the stroke data for that session on your phone. I repeat this process for different stroke labels and sometimes I vary my movement and power so our model doesn't overfit. This is what our dataset looks like. One CSV file represents one stroke, which consists of 3 axes of acceleration and 3 axes of gyro data. I collected about 50 samples per class across 6 categories, including an idle class called ZZZ for when you're not doing any stroke movement. Here's what those datasets look like once uploaded into Edge Impulse. We then configure digital signal processing with spectral analysis and then train our classification model. Here's our training performance metrics for our model based on the training parameters that we have configured. Once happy with the result, we can select Arduino library for our target deployment. Once downloaded, put it into the library directory so we can build an Arduino application on top of the model. The classifier needs 500 milliseconds of IMU data per prediction, but instead of waiting for one full window before starting over, it runs every 250 milliseconds on a rolling buffer. Each prediction overlaps the last by half, so every stroke gets 2 chances to be caught. Now let's see it in action. It classifies and counts every stroke that I make in this table tennis practice session. Here's the final result for my training session. Thanks for watching.